Hi, I'm Professor Dimitri Androutsos. I'm the Department Chair of Electrical, Computer, and Biomedical Engineering. My background is electrical engineering. I got my bachelor's, master's, and PhD at the University of Toronto, and currently been a professor here since 2004. Some interesting things about me. I'm very much into photography. I love digital photography, photography in general, and that comes directly from the fact that my graduate research was in the areas of image processing. I also like to travel and I like to ski. Electrical engineering, not just to me, but to everybody, is probably the most important engineering discipline that we have. If we think about it, what would our world be like without electrical engineering? It's so important to our daily lives. Nothing that we deal with these days can function without electricity. Electrical engineering provides electricity, so the theories for that and the hardware and the infrastructure is all based on electrical engineering. But beyond that, electrical engineering covers such a broad area of disciplines and fields that there are aspects of life that are part of electrical engineering that people don't even know. Quantum computing. I think quantum computing has potential, a seriously big potential. I think that is an area I'm keeping an eye on. But in my specific area of research, and which is image processing, I look at it every day, and it's always changing. What happened today, or what happened 2 years ago, seems to be outdated now. With the proliferation of AI and machine learning, my field of image processing and computer vision in those areas is changing so drastically that if I don't keep my eye on it, I feel that I don't understand anymore. If I don't look at it even for a year, there are so many things that are changing there. So I keep a close eye on what goes on in those areas. But one of the future ones that I think we have some big potential is quantum computing. Areas and fields of electrical engineering are so broad and so pervasive in our lives and society today, that the importance of electrical engineering to Canada's industrial sector and growth is paramount. Think about power itself. Just the electricity, the need for electricity in society today is more than it has ever been. There's a lot of research and development in finding efficient and effective ways to create energy, to transmit it, to have it sent to your home, to store it, and to use it efficiently. So just from that aspect alone, it's extremely important to Canada. But if you look at other sectors in Canada that are important in industry, technology is the number one area, if not in the top three areas of what Canada is working on in important industries. And when it comes to technology, nowadays, electronics, electric circuits, and media, and how that media is created and processed and communicated, and data communication and voice communication, all of these aspects are important sectors, of the most important sectors in Canadian industry. And electrical engineering is at the forefront of that. Electrical engineering is such a broad area that it always adapts and changes with what is going on in society. However, the major things that are on the horizon would have to be increasing solar technology or improving it. Those are big deals. I alluded again to the power grid and power distribution, creating more efficient ways of creating these power grids, for example, and being able to sustain these types of things. They're not revolutionary things, they're evolutionary things, but they're things that society requires as we go along. Another pioneering or breakthrough kind of area that's becoming very important, or increasingly more important, is electronics and robotics, or mechatronics, merging those two things together, autonomous cars, and the technology behind an autonomous car is very much electrical engineering. So those are things that I think are going to be very important in the coming future. Biomedical fields, there's a lot of electrical engineering in the biomedical fields and in the health medicine. What else? There's so many things. What can we possibly do in the future without electrical engineering? That's another way to look at it. It's becoming increasingly more and more pervasive, everything that comes out of electrical engineering. Electronics and circuits, everything today is based on electronics and circuits and microprocessors and CPUs. All of that is electrical engineering. That's who designs those. Those are the people who design those chips. Those are the people who design the algorithms and the architecture around those chips to work. I mean, there's computer engineers there too, but computer engineering is built on electrical engineering. I could go on. It's such a wide area. Lighting is another one. Optical communication, anything to do with optics is very much electrical engineering in the background. Again, I mentioned biomedical. There's so many aspects of biomedical engineering that are electrical engineering dependent. Very much of it, the devices that are used there, the signal analysis coming from the body are based on electrical engineering fundamentals. The list is endless. If you get a degree in electrical engineering, you can work in multitude of areas, and your skill sets can apply to a variety of areas of not only electrical and engineering, but computer engineering, biomedical engineering. You can work in mechanical fields. There's in aerospace. There's so many aspects. It is really the broadest of all engineering fields. I would say to pretty much all engineering students would be do as much programming as you possibly can, become competent in programming. Yes, electrical engineering is not programming. People would think that it's just computer engineering. It's not programming. However, programming is a required skill that applies to all areas of electrical engineering. Even if you were to work at Toronto Hydro or a power plant, they require people that know how to program there. Most of the controls of those systems and all that are done with software these days, and they require people who know how to program them, build them and program. So programming is an important aspect that I think many students are fearful of, and they don't want to do it. But I think that you need to force yourselves to learn that skill, and learning that skill is not just what you're taught in classes. I think that being able to do some online courses on your own and doing as much of it as you possibly can is an important tool to know and an important skill to have. And that applies, I think, to all engineering fields. I can give you my own example. I worked in, one of my positions was working in a company that did voice over IP, and I found myself, as we moved around in the company in different groups, I found myself once in one aspect of that job, writing code for the voice over IP aspect of the product. So I was actually writing C++ code and working with other people who were coding, debugging things and trying to write new algorithms and all that. But at the same time, people would come to me and they would ask me how to design a filter, because they required a filter for aspects of that project. And the people who were in computer science did not know how to design a filter. So sure, they could program, but they had no idea of the theory that was required and the know-how of designing a filter that worked in the voice pathway. So my skills were used in two ways. So the fact that I knew how to program, and I can say that those programming skills, not only were they developed in school, but I honed them on my own, doing my own projects. And during my graduate work, I used programming to simulate things. The fact that I knew how to program made me remain valuable to a company. And the fact that I had an electrical engineering background and I understood filters, I was able to provide even more value to this company. So I would say that's probably the biggest skill set, is knowing how to program. For students that are first starting at TMU, my advice is engineering is hard. Okay. It is not going to be an easy stroll through. There's a few that find it easy stroll, but majority of most students will find it challenging. Not just the material, but the workload. The adjustment from high school to university is a huge culture shock. But what it requires is perseverance. Okay, it requires you to work hard and try to work with a good study group and make sure you have study habits and allocate time to doing homework and assignments and try to keep up with these things. If you work hard through it and you persevere, it'll work out in the end. The other advice I can give students is that, if you do find it overwhelming, you shouldn't be forcing yourself to take on workload if it's too much. There is help available in the first year office and in later years. All you do is have to ask for it. There's ways to alleviate your schedule and to help with the workload that could help you cope with those things. Now, I know many students will come in here thinking, I got to finish in 4 years. But nobody says you have to finish in 4 years. If you take a little bit longer, but your mental state is better for it, there's nothing wrong with that. You don't want to be a nervous wreck coming out of here. You want to be able to also enjoy your time as a university student. So come and ask for help. That's what we are here for. You shouldn't shy away from asking for help from first year office and when you enter your second years in higher in your actual department's office that you're a part of. Ask for help. We're here to help you. We're here to give you options and ways to deal with things like stress and workload. But it is going to be a lot of work. There is no question. Engineering is a lot of work. I don't think anybody came in engineering thinking it's going to be an easy ride. Okay, it's a lot of work, but when you're done in the end, you have a degree that's worth a lot. You can do a lot with. And even if you don't do engineering in the end, the fact that an engineering degree teaches you how to think critically and to solve problems is knowledge and skills that can apply in many, many areas. There's many people who leave engineering and become lawyers and doctors, accountants, or business owners. If you get an engineering degree, you're going to have a great foundation to do whatever you want in the future. So just work hard, persevere. If you find it hard and overwhelming, what I can say is that's kind of an expectation. It's supposed to be, okay? But there's help for you. Ask for it. Make sure you may have a good group of study friends around you to support each other. These things are important. But when you get through it, you'll feel extremely proud and accomplished.